Welcome back, dear students. So today we are going to talk about a new topic, that is the single stage common emitter amplifier. It is also known as the RC coupled amplifier. Now this is the topic from the chapter Amplifiers in Electronics paper 2. Okay, I'm talking about class 11. So this is one of the very important topics, not just for class 11. Wherever you go in the entire electronics portion, I think this is one of the major topics. Even if you want to pursue engineering in future, this topic is not going to leave you. Okay, this is that important. So coming to the main aspect of this topic, single stage CE amplifier. Let us see each word in detail. Okay, so single stage means, देखो, for example, give you a very day-to-day life example. For example, आप बना रहे हो चाय, ठीक है? आप चाय बना रहे हो या फिर आपने देखा होगा किसी को चाय बनाते हुए. It's as simple as that, ठीक है? If you're making tea, आप क्या करोगे? First you'll take a filtering device. आप छलनी लोगे. चाय बनने के बाद आप छलनी से उसको डालोगे, राइट? एंड नीचे आपको फिल्टर्ड चाय मिलेगा. ये हो गया सिंगल स्टेज फिल्टरिंग. अगर ये छलनी के से चाय डालने के बाद भी आपको चाय में कुछ चाय पत्ती दिख रहे हैं, छोटे छोटे पीसेस, आप क्या करोगे? दोबारा एक और बार डाल दोगे, यू नो, इफ यू वांट टू डबल, तो उसको बोलेंगे आप मल्टी स्टेज फिल्टरिंग. ठीक है, सेम चीज सिग्नल्स में, इलेक्ट्रॉनिक सिग्नल्स के लिए भी यूज किया जाता है. इफ द सिग्नल इज वेरी वीक, you may not get the desired output in single stage. But multi stage सीखने के लिए हमको पहले single stage सीखना पड़ेगा, right? This is the reason why we are saying single stage amplifier first. Amplifier का क्या मतलब है? It is going to increase the power, it is going to increase the voltage of a particular weak signal. Okay, तो हम input में, for example, if we give a very low input weak signal, आपको output में उस ज्यादा voltage मिलेगा. You get a more amplified signal. So amplification का मतलब समझ में आ गया आपको? Amplify मतलब उसका power बढ़ाना. Input में, in the input you're going to give very low power input, and at the output you get considerably more powerful output. Okay, so this is the Iron Man of electronics. You can say you get very low input. If you give a very low power input, you get a considerably high power. I'm not saying बहुत high होगा, ऐसा नहीं होगा. एक single, after all it's just a transistor, right? तो considerably थोड़ा आपको power increase करके मिलेगा. You will get a little bit rise in the amplifier. And one more thing I want to address in this lecture. There were a few comments saying that, ma'am, please, can you completely speak in Hindi or you completely speak in English? I just want to clear this off because I cater to a larger number of children who are from, they are children who are not very well versed with English. Okay, so I need to look at them also. There were many kids who commented, ma'am, can you please talk completely in English? I would love to speak in English for the entire duration of my lecture. But after interacting with a few students, I've understood that there are some students who understand only if I speak in Hindi. Right? And what is knowledge if you are not understanding what I'm trying to say? So that is why, children, I'm using these two different languages so that both the communities, the kids who want English and the kids who want Hindi, दोनों खुश रहे. इसीलिए मैं दोनों languages में बात करूंगी. Okay, because all students are equal for me. Fine. Okay, so let's quickly get into the details. Single stage मतलब एक ही stage, एक ही छलनी यूज कर रहे हैं चाय निकालने के लिए. अगर आपको दो बार छलनी से निकालना है तो that becomes a multi stage. ठीक है, so this is a single stage. ये एक stage है. आप multi stage बनाएंगे तो क्या होगा? यही चीज आप एक और बार यहाँ पे लगाओगे, then it will become a multi stage amplifier. ठीक है, Now, next is CE. What is CE? CE means common emitter. If you can see, let us go to the basics of a transistor. A transistor looks something like this. It has got 3 terminals, which by now you must be, you should be knowing: base, collector, and emitter. Okay, so if you can see over here, this section is the input of the amplifier, and this section is the output of the amplifier. So what can you see? This emitter, ये जो emitter है, through the resistance, this is given to the input also, and this is taken to the output also. That means this is common in input and output. That is why the name is common emitter amplifier. Okay, I hope I have cleared all the first पूरा heading clear हो गया आपको, ठीक है? Now let us see what are the details of this particular amplifier circuit. Now first let us understand the circuit. Okay, ये बंदे को तो आप जानते हो. ये बंदे का नाम क्या है? What is this person's name? Transistor, the basic unit of amplification, right? This is the Iron Man. Now Iron Man को मुझे पहनाने हैं head gears, helmet, बाकी के जो उसके what you can say the power, वो सब मुझे बाकी attachments लगाने हैं. That's all I need to do. Okay, so the basic unit of amplification is this transistor. अब उसका helmet और बाकी का powering supply सब देना है हमको. Fine. So now this particular transistor, it has got 3 terminals, and this is connected to a voltage divider circuit. अगर आप देख रहे हो तो एक voltage divider circuit है input पे. Fine. So R1, R2, they cause the voltage divider bias. Input is given over here, and there are some capacitors, if you can see. Okay, so this capacitor, okay, capacitor, I will name this as, in many books the nomenclature is different, so please don't bother about that much. You can write C1, C2, you can write C in and C out, anything. So in Fadke publication textbook of class 11, it is C in and C out. So I am going to write C in and C out. Fine, it's not clear here, that is why I'm writing it. So C in and C out are 2 resistors. Okay, these are C in and C out are 2 coupling capacitors. Okay, now what is the role of these coupling capacitors? Coupling capacitors means they can pass only AC. They will block any DC coming through. ठीक है, क्योंकि यहाँ पे एक DC सप्लाई है ना, तो गलती से DC सर्किट में नहीं आना चाहिए, इसलिए कपलिंग कैपेसिटर्स लगाए गए हैं, so that only AC is passed, DC is blocked. तो एक शॉर्टकट है ये याद रखने के लिए कि कैपेसिटर DC ब्लॉक करता है कि AC ब्लॉक करता है. DC का सिग्नल कैसे दिखता है? स्ट्रेट लाइन है ना, DC सिग्नल है स्ट्रेट लाइन. तो ये देखो मैं स्ट्रेट लाइन ड्रॉ कर रही हूँ, समझो ये DC सिग्नल है, स्ट्रेट लाइन आ रहा है, 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 डूम, ब्लॉक हो गया. तो दैट मीन्स, मतलब ये एक व्हाट यू कैन से एक पिक्टोरियल रिप्रेजेंटेशन बोल सकते हो आप. कैपेसिटर ऑलवेज ब्लॉक्स डीसी एंड इट विल पास एसी. ठीक है, एसी आराम से पास हो जाएगा, देखो ऐसे 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 ऐसा आराम से पास हो जाएगा. ठीक है, जस्ट अ सिंपल पिक्टोरियल रिप्रेजेंटेशन सो दैट यू गाइस कैन रिमेंबर. ओके, द थ्योरी बिहाइंड इट इज डिफरेंट. सो सी इन एंड सी आउट का समझ में आ गया, वो डीसी को ब्लॉक करता है, एसी पास कर देता है, दे आर नोन एज कपलिंग कैपेसिटर्स. नाउ बेसिक, कमिंग बैक टू ट्रांजिस्टर, that only it can work as an amplifier only if it is biased in the active region. Okay, always remember A, active region amplifier, active region amplifier, because the transistor can be biased in according to 3 regions: saturation region, cutoff region, and active region. If it is biased in the active region, it can work as an amplifier. So आप A remember करोगे, active region for amplifier. Okay, now we can apply a small AC signal to the base and it produces fluctuations in the collector current. Okay, but there is, remember one thing, amplification का मतलब है it does not change the shape and the frequency of the signal. We are not touching the shape and the frequency of the circuit. Amplification is just like this. See, छोटा सा small signal, and over here you are going to get the same shape, same frequency. Only what is increased? the amplitude has increased, right? That is amplification. So no change in shape, no change in frequency. Okay, fine. So now there is one more thing I want to tell you on. This speciality is that very small, weak in base current is given. If base current is given, the transistor will be switched on and it produces change in the collector current. Okay, and the collector current, remember, this is the sign of the conventional current. Okay, flow of electrons is different. So this base current produces the change in collector current. और कलेक्टर करंट में क्या बोलते हैं वैल्यू चेंज हो जाता है, ऑब्वियसली एमिटर करंट का भी वैल्यू चेंज होगा. क्यों? बिकॉज IE is equal to, we have already learned this, IE is equal to IB plus IC, है ना? तो ये बंदा चेंज होगा, ये बंदा चेंज होगा, तो ऑब्वियसली ये भी बंदा चेंज होगा, right? So that is why IE will also change. Fine. Now for example, one more thing, current amplification factor beta of transistor. क्या है उसका formula? IC upon IB, right? IC upon IB. For example, beta is 100. Okay. For example, beta is 100. So what will be IC? IC will be, मैं IB को इस तरफ लेके जाती हूँ 100 times IB, है ना? तो IB कितना भी छोटा हो, फॉर एग्जाम्पल IB is 1 milliampere, IC will be 100 milliampere. तो आप समझ रहे हो रेशियो? कैन यू अंडरस्टैंड द रेशियो? For very small base current, you are getting considerably large collector current. That is why this is known as small signal amplifier. What is the other name of it? Small signal amplifier or linear amplifier. Linear relation है ना, इन दोनों में linear relation है. If IC increases, if IB increases, IC increases. If IB decreases, IC decreases. So there's a linear relationship. Therefore, it is known as linear amplifier. And for very small signals of IB, you get a considerably large amplification. Hence, it is known as small signal amplifier. कहाँ use होता है ये सब? ये radio receivers, TV receivers में first stage में ये use होता है. ठीक है? Fine. Let's get back to the circuit again. So the circuit as shown, voltage divider biasing is used. ठीक है? क्यों use किया voltage divider biasing? Biasing का वीडियो जाके देखिए. Advantages है कि उसका stabilization perfect है. ठीक है? It has got very good stabilization of operating point. Then C in CO, I already told they are coupling capacitors. They block DC. Okay, and they block DC इसलिए उनको blocking capacitors भी बोलते हैं. Now you can see one RC, that is the resistance connected across the collector. RE, this is the resistance connected across the emitter. Okay, there is one more capacitor CE, that is it is connected across RE. Right now, this is the bypass capacitor. इसको बोलते हैं bypass capacitor. What does it do? It bypasses all the AC currents that is coming from the emitter. Okay, so it as I told you, it passes AC, no? तो AC को ये यहाँ से ले लेता है और ground को दे देता है. Okay, क्यों ऐसे करता है? अगर CE नहीं होता, अगर ये हम नहीं connect करते यहाँ पे, so what will happen? The AC will cause a voltage drop across this. Okay, and this will go back. It will give a negative feedback over here. So then gain का बहुत problem होगा. It will give a feedback to this input, which causes a decrease in gain. हमको हमेशा gain high चाहिए. Gain क्या है? Gain means output upon input. ठीक है? तो मुझे output ज्यादा चाहिए ना, है ना? What is my aim? मैं उसको 1 millivolt दूंगी, तो मुझे at least कितना 20 millivolt मिलेगा output. I need more output. That means 20 millivolt upon 1 millivolt. What is my gain? 20. जितना ज्यादा gain उतना अच्छा, है ना? Right? It's just like the more knowledge you gain, the more better, right? So gain should be more. और अगर ये negative feedback जाएगा, the gain will decrease. That is why we need a bypass capacitor. So this is a bypass capacitor. It will bypass and take to the give it to the ground. Either ground connect कीजिएगा please. It will bypass all the AC signals. Okay, fine. Now, during the positive half cycle, what happens? Let us see. Okay, now during the positive half cycle, the base current increases. Okay, now as the base current increases, kya badega? IC and IE will also increase, because IE is equal to IB plus, as I had told before, IE is equal to IB plus IC. So during the positive half cycle, IB is given, IB increases. So IB increases, transistor is switched on, IC will also increase, and IE will also increase. Okay. Now see what happens. Now because you have IC increasing, there is a voltage drop across RC. Obviously, there will be a voltage drop. Voltage drop means, voltage means IC into RC. V is equal to IR, Ohm's law, IC equal to into RC. अब देखो क्या होता है. Just because there is a voltage drop, the voltage drop across RC increases. If IC increases, RC will also increase. अब देखो क्या होता है. Let us do a KVL over here. Total voltage VCC is equal to, यहाँ पे क्या है, कौन सा voltage drop आएगा यहाँ पे, IC RC plus, ये मैं सिर्फ इतने एरिया का कर रही हूँ. I'll just take a different color and show you. इतने एरिया में मुझे वोल्टेजेस का सम करना है, इतने एरिया में. ठीक है. One more another color and I am going to do, इधर मैं पॉइंट लिख रही हूँ VC. ठीक है. So VCC equal to टोटल जो सप्लाई है, VCC equal to ICRC प्लस इधर जो कलेक्टर वोल्टेज है VC. ठीक है. Therefore VC क्या हो जाएगा, VC is equal to, सिंपल मैथ्स कर रही हूँ मैं और कुछ भी नहीं, ICRC को मैं उस तरफ लेके जा रही हूँ, it becomes VCC minus ICRC. तो जितना ICRC बढ़ेगा उतना VCC में से माइनस होते जाएगा, है ना. So as ICRC increases, VC will decrease, right? For example, VCC is 15, ICRC is say 5. कितना हुआ VC? 10. ICRC बढ़ गया. ठीक है. ICRC बढ़ गया. अब ये हो गया है 5 के जगह पे, this has become now 10. कितना हो गया? 5. Are you understanding? That means as ICRC is increasing, VC is decreasing. Right? That means they उल्टा चल रहा है, ये लोग, ये दोनों उल्टे चल रहे हैं, and output is taken across VC, across the collector and ground. Hence, it will come in with 180-degree phase shift, something like this. Okay, that means for the positive, when it is positive half cycle, when positive half cycle, you are getting at the output a negative half cycle. Okay, this is the most important point of a CE amplifier. You get 180, that means 180-degree phase shift. 180 मतलब इतना part होने के बाद, there's नहीं, sorry, इतना नहीं, just इतना. It just went forward. I hope it's clear. I hope ये AC fundamentals वाला वीडियो देखिए. 180-degree phase shift मतलब इधर 0, ये वाले पीक पे है 90, ये वाले पॉइंट पे है 180, राइट. तो यहां से सिग्नल स्टार्ट हो रहा है, यहां से मेरा आउटपुट स्टार्ट हो रहा है, मतलब कितना फेज शिफ्ट हुआ? 180. सो जब इनपुट यहां से स्टार्ट हो रहा है, आउटपुट यू आर गेटिंग इन दिस पैटर्न. Okay, so this is the basic, this is all you need to understand about single stage CE amplifier. And why is it known as RC coupled? Because here I put a load resistance. If I put a load resistance RL, it is, the output is taken through a capacitor. Hence it is known as RC coupled amplifier. Okay, clear? RC coupled amplifier. So RC coupled पूछा तो don't forget to write this, draw this load resistance. Fine. Now let us find the gain of this particular amplifier. If this comes in the exam, you just need to explain the circuit diagram and in short explain the working. I have a document kept ready for this. I will show you just now. So this this question can be asked in this format. Draw the circuit diagram of single stage or RC coupled. Now, if RC coupled is asked, please do not forget to put the load resistance here. Okay, please do not forget to do that. If it is RC coupled, then you have to draw the load resistance, RL. Okay, it is given in Freq publication, so you need not worry. It is given in the book that you all are referring. I don't think that should be a problem. Fine. Okay, so we have done all. You can quickly take a screenshot of this. Okay, this is the explanation which I've already given. What is R1, R2, R3, what are capacitances, bypass capacitor, all this is done. Let's come down. This is what I wanted to show you. Gain, voltage gain, current gain, power gain. These are the three very, very important points over here. Gain का क्या मतलब होता है? Output upon input. तो अगर मैंने voltage gain बोला, gain को हम A से denote करते हैं. Okay, it is denoted by A. Fine. So if I'm just zooming in. If I say it is voltage gain, it will become AV. A stands for gain, V stands for voltage, voltage gain. So क्या होगा gain? Output voltage upon input voltage. Gain means, always remember, gain means, I'm writing in big bold letters, gain means output upon input. भले वो कुछ भी हो, okay, whatever parameter it is, gain means output upon input. Always remember this. Fine. So just, yeah, gain means output upon input. Always remember this. So if it is voltage gain, AV suffix will come. Output voltage upon input voltage. If it is current gain, then output current upon input current. If it is power gain, now pay attention. It is current gain in voltage gain into current gain. Okay, it is multiplication. Current gain into voltage gain into current gain. Fine. Clear? AV into AI. Is that clear? Fine. So these are the three formulae you need to remember. In this case, you may get a numerical saying output voltage of an amplifier, this was this much, input was this much. So what is the voltage gain? Or maybe current factors will be given. You will be asked to calculate current gain, etc. Okay. Now, all this is already done. Now let us go to the next part, the frequency response. What do you mean by frequency response? If you want, I'll show you the question which can be asked. Draw and explain the frequency response of RC coupled amplifier. Okay, this is what we are going to do now. Frequency response. Now, please understand the meaning of frequency response. Frequency response means for a particular range of frequencies, आपका एम्पलीफायर कैसे परफॉर्म कर रहा है. ठीक है, आपको रिपोर्ट कार्ड मिलता है कॉलेज में. You get report cards, right? For a period of 6 months or for a period of 3 months, how the student has performed. That is your response. I mean, that is the response we give for your performance. Same thing is this. Frequency response means how that particular transistor, amplifier has performed for this range of frequencies. Okay, so can you see this? This is the range of frequency. और उसका क्या gain है? This is the gain. This is the response. That means for low frequencies, this is 0. Okay, for low frequencies, the gain is less, but it is improving. Okay, mid-section of frequencies, it is stable. And high frequencies, it is again very poor gain. It is coming down. Okay, so these are the 3 sections of frequencies. Lower, this is, you need not go into the details. I have given it in details, but you need not go into the details of this. And this section, frequency response, is given on page number 180 of Freq publication, class 11. Page number 180. Okay, so you, in case you want to refer to it, you can refer. Now, let us see. Okay, it is generally plotted against, I told you, x-axis mein generally frequency hota hai, and y-axis is generally voltage gain or output voltage, generally gain. Okay, now it is generally plotted on semi-log graph paper and with frequency on logarithmic scale. Fine. Now, I told you there are 3 ranges. first stage region is lower frequency region. Fine. Now in this lower frequency region, if you can see, the curve is increasing, but it is low, right? Because here the capacitance is coming to picture, and capacitance is Xc is equal to 1 upon 2 pi Fc. तो Xc मतलब रिएक्टेंस है, रिएक्टेंस मतलब क्या है? रेजिस्टेंस जैसा, मतलब आप दौड़ने की कोशिश कर रहे हो, पीछे से वो खींच रहा है, दैट इज रेजिस्टेंस, ठीक है? तो it is inversely proportional. If you can see, Xc is inversely proportional to F. F jitna kam utna zyada resistance. That is why it is low. That is why the gain is low. Okay, so at very low frequencies, the reactance of these coupling capacitors is high. That is why it will act as open circuit, and therefore output voltage also falls down. That is why it is low. Okay. Now in mid section, let's come to the mid section. That is the second point. In mid section, there is uniform gain because coupling and bypass capacitors are as good as short circuits. Okay, so the gain remains nearly constant. Now let us see in the third region, that is high frequency region mein kya ho raha hai. Now during this high frequency region, beta also depends on frequency. Okay, and beta decreases at high frequencies. Therefore, the voltage gain again decreases. Okay, so this is the frequency response of the CE amplifier or RC coupled amplifier. If the question is asked to explain, you will draw this and you will explain the three regions. I hope this concept is clear. Any doubts, please feel free to ask. And here we end this topic. Have a good day and bye-bye.